let rho r equals to q by 4 q by pi r raised to the power 4 times r be the charge density distribution of for a solid sphere of radius r, total charge q for a point p inside the sphere at a distance r1 from the center of the sphere, the magnitude of electric field is. So here they're asking us to calculate the magnitude of electric field. Okay, and the charge density is given, that is non-uniform. It has radial symmetry and it is increasing as we move away from the center. So let us consider this as our sphere, and in that we are going to consider a spherical shell of radius r and thickness dr over here. So let us assume the radius of this one be r here, and its thickness I am assuming it to be dr. Okay, and this is basically the strip that I have taken here. Okay, this is our strip. Now if I calculate amount of charge enclosed in this strip, that is dq. So dq I will be writing it as a rho times 4 pi r square dr. dq I will be writing it as a 4 pi r square dr times rho. Remember, rho is not constant here, rho is variable, but for this small distance from r to dr I can assume rho to be constant. For r to dr we can assume rho to be constant because this distance is very small, so we can assume our rho to be constant there. So now if I substitute the value of rho in this case, then I will be writing q divided by this is pi r raised to the power 4, and this is r, and then I will write 4 pi r square dr. So for total q, if I write q total, then for q total I need to integrate this dq, and when we integrate this dq, then you can see q by pi r raised to the power 4, and then 4 pi from this side. These are the constant that I have taken out, and this is rq dr, and we will be integrating it from 0 to r1, 0 to r1. So when we integrate it from 0 to r1, the value that we will get here, the value will come out to be pi and pi will cancel, and we will get q by r raised to the power 4. 4 will also be there, 4 q by r raised to the power 4, and rq dr integration will be r raised to the power 4 by 4, and the limit will go from 0 to r1. So we will get the value here as q by r raised to the power 4, and this is r1 raised to the power 4 here. So we got the q total that is enclosed in this entire region, the total charge that is enclosed in this region. We have got this value of q. Now once we got the value of q, then we can easily calculate the electric field at this position at distance r1 from the center. So E I will be writing it as a k, q enclosed by r square. So the electric field we will get here, k will be written as 1 upon 4 pi epsilon naught, and q enclosed is q by r raised to the power 4, and this is r1 raised to the power 4 by r square, r1 square basically. So on simplification we will get here q by 4 pi epsilon naught r raised to the power 4 here, and this will become r1 4 by r square will give you r1 of square. So that will be the answer to our given problem.